My name is Mike. I'm one of the founders of RethinkDB. RethinkDB is an open source database. It's really easy to scale. It's designed for real-time apps, and it's a document database. So RethinkDB is an open source project. It's actually the top document database on GitHub right now in terms of stars. We actually just crossed the 10,000 star threshold, I think like about 2 weeks ago, which is awesome. So if you haven't started yet, go star it. Helps with the visibility of the project. I started the company with, and the project with my co-founder Slava, his background is distributed systems, mine's in user experience. And we started about like 5 years ago. We've been working on it for 5 years now. It's been out in the public for about 2 years. And since then, a ton of people started using it. And there's been a huge explosion of innovation in the world of real-time apps. And that's what I really want to talk to you about right now, because that's what makes RethinkDB really special. So I want to say, what do I mean by a real-time app? Because that means a lot of things to a lot of different people. Everyone probably remembers their first experience when they used Google Docs. You open up your browser and you see like this like white document blinking cursor, and you're like, oh, it's a text editor, I know what this is. But then you see people start to type, and you're like, wait a minute, this is something else entirely. Like now I'm getting feedback on the data that I'm getting from other people, and it feels like very visceral. It's a very like real experience. I think a lot of people remember that first moment. And this kind of user experience is what people really want to build because it's very visceral, it's very emotional. But it's really hard to do so. Another example of the kind of apps I'm talking about, who here uses Slack? Raise your hands if you use Slack. Yeah, that's right, the whole room, because Slack is taking over. And the thing about Slack, it's funny, it's just chat. People have tried to do chat, I don't know how many times before. Slack just did it right. And I get an email every week which says like the summary for my team, and I consistently get most emoji. And I'm going to hold on to that title. And the great thing about Slack is that it doesn't matter if you're on your mobile phone or if you're on your browser. It sort of just feels, if you're on the desktop client, it feels like you're just working with your team the whole time. And the reason why is because as you're using it, things are popping in at you, notifications are coming in, and you just sort of feel connected to your team, and that emotional experience is like amazing user experience. It's what people really want. But the problem is, it's really hard to build these kinds of apps. And I want to talk about like why, from an architectural perspective. If you ever had to build one of these before, you start on the front end, and there's like amazing tools now between React, Angular, Netflix released Falcor. There's a bunch of amazing tools to be able to build real-time apps on the JavaScript side. But as you start to get lower in the stack and start to actually build like a big application, like you want to roll out for your team or for your company, for your startup, it starts to get really hard. And the biggest issue is that it's really hard to keep track of state when you have a real-time architecture. What do I mean by state? So I hate architecture diagrams, but I want to show you just one or two, so bear with me, because they actually help in understanding what we're talking about. If you have like an architecture for a real-time app, this is what it usually looks like. At the top you have, let's take Slack. You have like your web apps and your mobile app servers. Sometimes you have different servers because let's say your mobile app needs like push notifications or has different requirements than your web server does. So you have a bunch of them running in parallel. But in order to keep track of state, you can't keep hitting the database because the database is slower, and you can't push messages to and from the database. So you usually use a message queue, something like RabbitMQ or Kafka, something to be able to basically push messages around. And the problem is now that what you've done is you've split your state, the source of truth, the sense of reality, what's actually happening as it's occurring in real time. It's split between the database, between the messages in the queue, and between what's happening on the app servers. And so now, because you have to keep track of what's happening in real time in multiple locations, it gets really hard. And the only way you can really keep track of what's happening on the database side is to pull the database. You have a question, a query, some question, let's say, give me everyone who is within 2 miles of this geolocation and tweeted between the hours of like 2 a.m. and 7 a.m. every second Thursday of the month. That's like a question, that's a query, right? And if you want to keep track of it, you have to pull the database, you have to constantly be asking the same question over and over every 5 milliseconds to be able to keep track and give that real-time experience. That's really cumbersome. And because of this, because it's really hard to figure out what the source of truth is, it's hard to figure out what the state is. And it's also hard to figure out how to scale the database when you're pulling the system. Adding new real-time functionality keeps getting harder. So your team is like, well, we want to add a new feature, but we really can't because we don't know how to do it, because frankly it's hard to scale. There are a few teams with engineering resources in the size of teams like Facebook and Google. Quora had a great talk, if you guys want to look it up. It's an amazing talk on when they were building Quora, which has real-time commenting, where like things will update live as people like edit their answers. They gave a great talk on their CTO on how they built Quora, and none of the architectures, none of the tools we have nowadays existed then. But just looking at the level of complexity from browser to server, it's absolutely immense. And so it's hard to keep adding real-time features. And if you've built these kind of systems, I'm going to add one more point which will sort of resonate with people who've dealt with this problem before. If you have to figure out, how do I route these messages now? I have like channels on Slack. Not everyone should see all the updates. So now I have to figure out, how do I figure out who should get the message? Should I broadcast it to everybody, or do I have to figure out how to route them from place to place, and which piece of software in that architecture is responsible for it? So all these problems are really hard. So that brings us to RethinkDB. I want to quickly say what RethinkDB is. We're going to dive into it in a moment. It's 3 things you should know. 1, it's an open source database. It makes it really easy to build these kinds of apps. Because what we have is fundamentally a push architecture where data is pushed from the database. The second is that it's a NoSQL database. It's a document store. The model is JSON. We picked JSON because that's the common data format for the web. And it's distributed database. We just designed it to be really easy to scale, and it's fault tolerant, high availability, so as nodes go down, nodes will come up to keep it running. So I mentioned that it's built for real-time apps. I want to talk about what that actually means. So the fundamental thing that's special about RethinkDB in my mind, there's a lot of things that are great. It's a great general purpose database. But the thing that makes it really shine is that it lets you subscribe to change notifications on database queries. And what that means is, if we look at this, this users table, so this is an example query that we call our query language a requel instead of SQL. And so this is an example requel query where we are following r.table and the users table .changes. And this will open a feed, a stream. And what will happen is every time a document is added, modified, or removed, you get a little push notification, a little ping that says, hey, something changed in the table, and you get pushed that to your application directly. So instead of having to pull it to find out what's changed, instead you get pushed. So instead of polling, the database is pushing with a live stream of updates. This is like the fundamental piece that we provide that we then build on top of to help you build these real-time apps. So change feeds, they let you build scalable real-time apps. So in this example, same thing again, it's much simpler because in this case, your servers are not communicating with each other in any way. They're not pushing messages to each other. They push their new data to the cluster, and then the RethinkDB cluster, they all subscribe to change feeds, and the cluster then pushes them updates as it receives them. So these servers are then stateless. They know nothing about each other, which means you can scale them as much as you want. Just keep adding servers and keep opening change feeds. And change feeds are as cheap as a connection. You can open an enormous number of connections, and so you can basically keep scaling these real-time app servers. So I keep talking about real-time apps. I just want to talk about some use cases because it gets really exciting. Some examples, you have like web and mobile apps. We know these, Google Docs, Slack. Multiplayer games are a good example of where this is really important. You have like player events that are all happening in series. You have a game world where people are interacting. You want to maintain a consistent version of reality, a consistent version of state. If you have streaming analytics where you have like lots of data that's pouring in real time, rather than bundling it off every 48 hours or 24 hours to send it off to an analytics database to figure out what's changed within my, within my team, within the product that we've shipped. Instead, you can just get live updates as they come, and it'll push it to an analytics app. Bidding on real-time like ads, things like that in a real-time marketplace. And my personal favorite, because we've been talking about like the Internet of Things for maybe 20 years now, but it's actually happening now. We have tons of devices that are deployed that are all like pushing data around and collecting data. And it's all transient data that has value only in its immediacy. Like in that moment, if you capture it and you can take advantage of it and react to it, you can actually affect massive change. If you have a farm deployed with sensors that's tracking like moisture and humidity and sunlight and trying to figure out when's the ideal time to do variable fertilization and deploy, deploy all the farm equipment to be able to actually like get optimum yield, that only is relevant in its immediacy. Or if you have like your Fitbit and you want to stream like data to your friends as you're working out, like that can only happen in its immediacy. That data isn't really interesting to anybody 3 days later. No one cares you took a run 3 days ago. They want to know in that moment, oh, hey, my friend took a run and worked out. So with that, I just want to take a quick 2-minute detour to talk about what it's like to query RethinkDB, because then we're going to look at an example. So this guy, by the way, is our little mascot. He's the thinker. He's stuffed with creativity. And he, so this is an example. He's going to keep showing up throughout the deck. But this is an example of a query. We're counting the unique last names in requel. So we start with accessing the database table with r.table, and then we pluck it with isolating the document property .pluck for the last name. You'll notice that what we're doing is chaining. In SQL, you send over a string to the database, which means that when you're programming, you're kind of like moving from, oh, I'm writing my application to I'm writing SQL. And sort of that context switch is a little bit frustrating. And if you've used things like Mongo or other systems, in Mongo you like send over a JSON object that represents the operation you want to make to the database with their special operators. We chose to do a little bit differently because we're a bunch of programming language geeks. And so what we did is we designed requel to be able to embed into your native programming language, and it feels and looks like native code. So in this case, we then do .distinct. We try to pick properties and names that people are familiar with from tools like underscore, things like that, so it just feels like you're playing with data. And then count will count the number of items. So in this case, I mentioned that the query language, it embeds natively. You chain out your queries. It's composable. It's functional. And then these queries, when you chain them out, they're then executed and distributed on the server. And this is a little bit of magic we do, where when you write a query, it looks and feels like native JavaScript, Python, Ruby. There's 20 plus other languages. We actually just added, we're working on it. There's an open branch on Git that you can check out if you want, for an fourth official driver for Java, which will bring it to the JVM languages like Scala and Clojure as well. And so what you can do is basically you write out your chain, you feels like native code, you use your debugging tools, and then the query runs on the server in a distributed fashion. And so you have efficient, it feels like you're writing native code, but it's actually happening on the server in a distributed fashion, in an efficient distributed fashion. So REQL is pretty powerful. You can do a lot of things with it, like group map reduce, geolocation, inserting binary data into the database. You have control flow. It's basically a programming language that we kind of snuck in and masqueraded as a query language. So with that in mind, that's just a quick overview of REQL, so you know how do you interact with the database. So here's the magical part. This is why we looked at REQL, because now I can show you an example of a query where change feeds work on queries. So if we have this query where we're looking up user profiles to get over 30 likes, let's say on my social network that I'm building. So I say r.table profiles, I filter it, I give it an expression where I'm saying for each document, likes, everyone that has greater than 30, that's a query that I can run. And then to open a stream on it, I just add .changes and chain it at the end. And now I get this real-time stream of updates. Whenever that changes, I get a little ping notification that that's happened. So we're going to play with a quick example. If you guys could open your laptops, we're going to hope that this works with the network, but go to questions.rethinkdb.com. It's going to jump out of this right now. And so what I've built here, it's a little demo app. Pardon me for my mediocre CSS. But basically, what I want you to do is just ask me questions about RethinkDB. I'm not going to have time to go into all of them right now, but we'll try to hit the big ones. Yeah. But if you want to find me afterwards, I'm the guy who's bald and with the RethinkDB t-shirt. Does it blend? Does it have joins? I'll say quickly, yes, it does have joins. It does cross-table operations, so you have distributed efficient joins with RethinkDB. So try to upvote those questions, and you'll see that it's reacting in real time. Now, right now, nothing really interesting is happening because they're talking to the database, but it's really like the same app. You've seen this a million times. But what I'm going to show you right now is we also have a second app that I built, which is a little dashboard. And this dashboard is tracking the real-time questions you guys are upvoting. And here's the part that's interesting. These two apps know nothing about each other. They're not talking to each other. The only thing connecting them is RethinkDB. They're completely stateless. We could add 50 other apps, and they wouldn't have to talk to each other at all. But the thing that's connecting them is just RethinkDB. So keep voting. Keep looking at these. We're going to look at another little bit of magic here. So with RethinkDB, we wanted it to feel like you're using a database, but it doesn't have to feel like you're using like a database. It should feel like you're just developing with a friendly environment. So we built this thing which is available with every node in RethinkDB. When you start it up, you get this beautiful UI, which basically, and you can see, look, you guys are writing to the database. Look at that. So this is you get this for each node of the cluster. And you can see you get a bunch of info on what's happening, like servers, tables, things like that. And what we're going to do is I'm going to hop over. I'll show you quickly. We have like questions in the questions table. It's going to take a second for it to load here because the network's spotty. But let's hop over to the Data Explorer, actually. Let's write some queries. So let's see here. I think our network is dropping out on us here. That's unfortunate. Okay, so instead I'm just going to talk to you. Oh, there we go. It'll take a little late. I think the latency is really high, so let's just wait a little bit. But here's an example. So what I did is I'm going to bump the font size. So what we have here are the documents that are sitting inside of my questions table. And these are the questions you guys asked. And so what we have here is just, it just looks like we wrote a query and got a response. I'm just going to add changes on the end. We'll run this. Okay, so now we have a real-time stream. You can see that, let's examine the output because this is actually interesting. So what's happening here is you'll see that we have new val and old val. This is how a change feed looks. What you get is you get basically a change notification that consists of two properties. Your new value, your old value. Now you can see in this case like the votes are going up because you can't like rename questions. But if old value was null, which if someone adds a new question we might see it. If old value is null, then that means that it didn't exist before. If new value is null, it means it was deleted. So you can see how in your app you can basically figure out like when questions are being added or removed and just apply the diff. And change feeds are getting much more powerful. We're adding the ability to restart feeds from scratch and being able to actually, at some point soon, hopefully replay it from a timestamp, things like that. So change feeds are pretty magical. And now I'm going to show you a couple other things. So let's say I don't like a certain question. Let's find a question. So I'm just going to pause this. All right, so I don't like this question null because you're not asking a question. That's just null. And if you guys are, by the way, going to try to do SQL injection or anything, it's not going to work because we don't parse any strings. There we go. Bobby tables doesn't work. So, all right. But please don't try to mess with it because I'm doing a demo. Okay, so have a little bit of empathy. So I'm going to grab a question. Actually, let's see here. Man, you guys are asking a lot of questions. So I'm not sure we're going to be able to see these. Let's see. So I'm going to ask a question here. Okay, so I have a question here, and I'm not sure we're going to be able to observe this because we have so many questions that are coming in. But if I just do .delete from the database, that question should just, there we go. That question should just disappear from the set. Yeah, so we have too many that are coming in quickly to be able to observe this. But basically, if you just do a delete from the database, it then sends a push notification to every single server, and it says, hey, that question doesn't exist anymore, you should delete it. So you can see how basically RethinkDB is the central source of truth for this entire real-time architecture. And I want to show you just one more thing, which is if we do, let's run a more complex query. I have my history open here because I don't want to type a lot right now. And I'm going to just first run a query, which is basically, let's look at it quickly. I'm doing order by, and then I'm saying use my index that I created on this field points. And I'm doing r.descending because order by will do it from the bottom, so I want the 5 top questions. So I flip it using r.descending, and I say give me the top 5 with .limit 5. So we can see those, run this query. All right, so these are the top 5 questions. Wow, guys, does it blend? Really, number 2? Okay, so what I can do then is I can say I only want to see the ones that apply to those top ones. So I then do .changes on that. And now I'm gonna see a stream, and all it's gonna send me updates on are those top 5 questions. So you can see how you can basically scope these change feeds and use the query language and just drop changes at the end of a stream, and you're able to sort of write these. It's a fluent API, data flows from left to right, and you're able to basically chain out and figure out exactly what your change feed should mean. So you can basically open an enormous number of change feeds, and they can all be scoped to the need for each individual app server and even each individual user. Okay, so I'm going to return to the deck now. We'll look at these questions in a second. So you can check the code out yourself. My name is Russian, long, and hard to spell. But if you want to find me afterwards, I'll point you to the repo for this. It's really simple. I wrote it in Node, and I used a front-end framework called Vue.js, which is super light and minimal. And then it's just socket.io. And what's happening is basically that RethinkDB is passing it up to the Node server, and then it's passing it up to my front end. And it's all real-time from bottom to top. This is what the architecture looks like. We had our 2 question servers that were running independently, and our dashboard server, they don't know anything about each other, again, and RethinkDB is the only thing that's connecting them. So let's talk about what this actually means and why RethinkDB actually makes it a lot easier to build these kinds of apps. So as I mentioned, polling for data, it's slow, it's cumbersome, it's hard to maintain. Polling is awful. No one likes polling. The push access model, where things push up, unidirectional data flow from bottom to top, it simplifies real-time architecture. And one source of truth makes it really easy to manage state. When you know that your source of truth is in one location, you know exactly where to look and exactly how to figure out what's your latest version of reality. And so RethinkDB is the first database that does this. It's the first database for the real-time web. If you guys are interested in looking at this or want to talk to me more about it, you should go check out the docs. They're super easy to get started with. We spent a lot of time trying to make them easy and friendly to get up and running with. It's easy to install. If you have a Mac and Homebrew, brew install RethinkDB. If not, there's a package. And if you run any common Linux distribution, it's pretty easy to get. We also have, we've been working on this for a while now because RethinkDB, it's a very deep product. It goes from like JavaScript to assembly because it's like custom coroutine implementations and really low-level stuff. So we've been working for a few months now, and hopefully it'll be arriving soon, is a Windows port, which I think is the #1 most requested feature that we have on GitHub right now. There's a lot of really interesting things going on the issue tracker. The team basically, we all feel like we're open source developers who are paid for our time, and we work like we accept direction and we work together because we know that we can like accomplish great things as a team instead of individually. And so if you want to find out what we're doing, and we do all of our work on GitHub issues, every single day there's just like nonstop things that are happening on the issues. So if you're interested, you have ideas on where to take this, just go in the issue tracker, open an issue, and just come participate in the discussion. So I'm going to go ahead and take a look at these questions for a second. We're going to see if we can spot a few. If anybody has anything you just want to ask me, raise your hand. You can do that now. I think we have a few more minutes. How are we doing on time? Great. Okay, perfect. Just give me a little notification. 10 minutes. Okay, perfect. Are there any questions anybody has before we dive into these? Go ahead. Yeah. 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 Yeah, so because we didn't want to make it super frustrating, because JSON is like, you have properties that are sometimes absent and sometimes not. Like that's the way that you have user-generated content and apps that are evolving quickly. So in some cases, you're able to look for it, like we have in the REQL language, there are ways to isolate document properties that are missing from documents. But by default, we won't like throw if a document's missing, it'll just keep going. Does that make sense? Should make it easy to develop these kind of web and mobile apps. Any other questions before we dive into these? Go ahead. File size that we limit, it's pretty high because people have pretty deep documents. I know we upped it recently. I don't remember what the size is, but if you come talk to me afterwards, you can go look. We also let people store binary objects in the database. So I don't recommend this for like large images or videos or things like that, but like storing user avatars and things like that, it just basically turns it into, UU encodes it and puts it into the database. So it's pretty hefty. We have people with pretty sizable JSON objects, like researchers who are working on like genetic modeling and things like that, where they have like really gigantic objects. So it should be fine, but if you have a use case, let's talk about it. Cool. Anything else, or should I dive into these? What's that? What is gigantic? Oh, in terms of the cluster sizes that people are running? File size. I'd have to go look at the numbers it is right now, because I think we just upped it recently. In terms of the size of RethinkDB clusters, we have reports of people running in like multiple hundreds of gigabytes and possibly higher. So we're doing a lot of performance testing right now on large scale, and we're testing in the area of like 10 to 25 nodes, but we have reports of people running even larger clusters. Okay, so let's go look at these. Let's see what we got here. I think our network is dropping out on us. All right, cool. All right, full text searching. So we actually, so you can do search using like regular expressions. I don't recommend it. This is not a full text search database. What I do recommend is using, we have a Logstash plugin for Elasticsearch. Elasticsearch is awesome. It's great for search. So if you need to do heavy searches, like people use RethinkDB with Elasticsearch, it's a common setup. If not, you can use regular expressions. Lunch, I'm excited about that too. Okay, so how does it handle database injection? It doesn't so there isn't database injection because there are no strings that are parsed. So there isn't a possibility of that. Which question is that? Do you host it or do I? Oh, I'm sorry. I thought you meant this event. I didn't realize you meant RethinkDB hosting. I was very confused. There's a lot of questions about the conference. So, okay, so so we don't host it ourselves, but we partnered with a great company called Compose.io. They used to be called MongoHQ, but they started offering Redis, Elasticsearch, RethinkDB, and they actually just got, I think, acquired by IBM, and so they have a lot of resources. They've been working with us for a while. We have a very close relationship. It's also, the Docker library, there's an official Docker image, so they maintain it, so it's really easy to get up and running with Docker. I usually use DigitalOcean myself for simple applications, or running on bare metal too always works really well. I think Joint has a great service for Docker, which is really great as well. So there's a lot of options. I think it's in the Amazon Web Services, like the store as well, so where you want to run it, you probably can. Okay, this is 42, very clearly. What's the overhead of a complex query as a change feed? The overhead is really not that much. The reason why we're able to do change feeds, it's because at a really low level, we built RethinkDB to be enormously parallelized and distributed. It's not just distributed across nodes, it's actually distributed across cores on the machine. So you have a multi-core processor, you have like, each core is responsible for a chunk of data, and then each core talks to the storage, and the storage is split up, so each core just talks to one bit of the storage. You have an SSD, massively parallel device, you're able to have these huge parallel operations. And then we did a lot of work. We have, like I mentioned, a custom coroutine implementation. So holding onto these change feeds in the architecture is really simple because we designed it correctly about 5 years ago. So it's why it's a little bit harder for other people to implement, because it would be an overhead complex query where you'd have to constantly pull and update, keep things in memory. How does it handle the connection, WebSockets? So basically, the driver will open a stream for you in, let's say, Python or Ruby, and then you would open up like an asynchronous thread to follow it. In Node, this is really easy to do. And then you can use whatever you want to push it up. So Socket.io is a great choice if you're in JavaScript, because it works with WebSockets and falls back to other protocols. If you're in Ruby, there's Fay, and there's a bunch of other different projects for each ecosystem. Will there be a Heroku add-on? I know people do run it on Heroku using Compose.io. We can try to, if you want to find me later, we can try to find out how that user did it. But we haven't officially announced a Heroku add-on yet. Stop deleting me. How does it scale? So it's actually really easy to scale. I'm just going to show you briefly. In the UI, you have this view on the table. And it'll take a few seconds for it to load because of the network. 4 minutes, OK. So here's what the table looks like. And you can see we still have reads and writes happening to it. And you have this like graph of how the system's going to be sharded. When I hit this button, reconfigure, I get this nice little UI. I only have one server, so it won't actually show you how to do this. But I can increase the number of replicas, the number of shards. And then I could just apply configuration, and it's just going to go and rebalance it for me. The other two ways that you can do it, and this is pretty cool. If I go to the Data Explorer and I open the system table, so we have a set of tables we present to the user for configuration, which basically will show you things like the configuration of the cluster, the current running jobs in the system, the statistics of it. So you can just go to the cluster configuration, and you can update it using Requel itself. I just want to show you this. This is pretty cool. If we do stats, we run this. So you can see the statistics, and then I can just open a change feed on it. And then now I have a live feed on the statistics as they're updating. And in fact, this whole UI is built using change feeds. So if you want to build your own UI and you want to monitor some job, or you want to be able to update your cluster configuration but not use what we've provided, you could just build your own UI pretty easily. OK, let's go back to the questions, because we have time for, I think, 1 or 2 more. Yeah, go ahead. Could you repeat your question? I'm not sure I follow quite yet. Oh, yes. OK. Yeah, that's a great question. So the great thing about Requel queries, you're chaining them out, but it's also composable. So you can write a function that has part of the chain, and then just like have an argument to that function, and then be, for example, the user's query that they had on the server. And then you can just compose the functions together, and now you've changed the query you're sending to the server, and just reopen the change feed. I can show you later in person, because it's magical, but we don't have time for it. So do I have time for one more question, or are we out of time? Yeah, go ahead. Yes. It's a great question, yes. So we actually have a pretty close relationship with those guys. We've been talking privately a lot about Meteor. Meteor, if you guys aren't familiar, is a full stack real-time framework that goes from database to JavaScript. And it uses MongoDB under the hood, and a lot of folks want RethinkDB because it's a good fit for it. The great thing is, the problem that we had is that the change notifications aren't correlated with timestamps that they need to be able to update for the reactive component. And so we're adding that. I think it should be shipping in the next version. So it's like we put the framework in place. We have an exciting thing that we're working on. If you look up on the GitHub issue for plugins, for the plugin framework, we're speccing out something where we're going to be able to run any plugin on top of RethinkDB, which means you could write arbitrary JavaScript, HTML, CSS, and add your own functions to RethinkDB. So for example, if you wanted to do React like GraphQL implementation, and run React apps directly on RethinkDB, that may be possible in the near future. So if you want to be able to check out that issue and sort of look at it, comment on it, have some feedback, it's a really exciting thing because plugins will let us vastly expand what RethinkDB can do. I think we're probably out of time, is that right? 1 minute, okay. Let's see if we can get one more question, unless somebody in the audience has one. There we go. Oh, sorry, I think we have two. Let's start with him if you don't mind. Go ahead. Performance when the, okay, so it depends on how you've set it up. If you have, for example, if you allow outdated reads, because you can configure it so that if you need to have, because we're a consistent first database, immediately consistent. When you write to the database, by default, it writes to disk first and then acts back. You can turn that off if you like, but it's immediately consistent. So if a master goes down, then it will need to re-elect one. That will take time for it to re-elect one using the Raft consensus algorithm. But if you allow outdated reads, it can go to secondaries and figure out who else it can get the read from. So it depends on how you've configured it, but it's pretty much linearly scalable. We've done a lot of tests, and there's a couple things we're working out, but for the most part, it scales really well. Yeah. What was your question, briefly? CLI. CLI, oh, like a RethinkDB CLI. Yeah, so people interact with RethinkDB primarily through Requel, but there are actually two great, there's ReCLI and Requel-CLI. Both are like community things that people have built. It just basically gives you like a front end from your command line, and they're both pretty useful. So, cool. I think we're out of time, right? So if you guys want to come find me afterwards, if I didn't answer your question, or just want to talk about RethinkDB or real-time apps, just come find me, okay? Thanks a lot, guys.